All right, today we will be talking about how to predict motion based on position time graphs like the kind that you made in your position time lab. So first up is the starting position. To find the starting position of an object from a position time graph, it's just the y-intercept. So remember, that's where the line crosses the y-axis, that's the vertical axis. So remember that from algebra class. To find the starting position here, we just find our y-intercept, which is right here at 9 meters. So our starting position is just 9 meters. If we want to find different points on the graph, so let's say we want to find a position at a given time or a time that we're at a specific spot, we just read the corresponding point on the graph. So if we look at this question, it is, what is the position at 4 seconds? So we just go down here, find 4 seconds, trace it up, find where we hit that point on the graph. And then if we trace it over, we can see we're at 7 meters. So at 7 meters or at 4 seconds, we are at a position of 7 meters because that's what this point is on the graph. If we want to find out what time do we get to a position of 5 meters, we just go back and basically do the same thing in reverse. So go to 5 meters, trace it over, find out where the line is. So it looks like it's right here. And then there's our point, and we can just read that point, and that time is 8 seconds. So we're just reading the graph at the given value to find the other value. If we want to extrapolate data, that means if we want to find out something that's like off the graph. So in this case, the question is, what is the position at 12 seconds? We can't just read the graph now because our graph ends at 10 seconds. So we could either draw a line to continue it, or we can make a data table, or we can make an equation. So we'll start first with a data table. If we take a look at this data table, we're just counting by twos here. So we are going to fill it in and try and look for a pattern. So if we start at 4 seconds and then go up to 6, 8, 10, we're just counting by twos, and that eventually gets us to 12 seconds. If we fill in our values, at 4, our position is 7, and then at 6, we're at 6, and then at 8, we're at 5, at 10, we're at 4, and then at 12, we're at 3. So if you look at our graph, we're just going down 1 meter every 2 seconds. So down 1 meter takes 2 seconds, 1 more meter, 2 seconds, 1 more meter, 2 seconds. So if this pattern continues, 1 more meter, 2 seconds later at 12, we would be at 3. We can also do this with an equation. So remember from math class, this is just linear here. So that's y equals mx plus b. Remember, m is our slope. So that's just rise over run. So we go down 1 and over 2. So that's why we get a slope of negative 1 over 2, because we're going down 1 over 2 seconds. So down 1 over 2, down 1 over 2. That's our repeating pattern here. And b, remember, is our y-intercept. So in this case, our y-intercept was 9, like we said, for starting position. So this is our equation. And then if we want to find the position at 12 seconds, we can just plug 12 in and then do our work. So negative 1/2 times 12 is negative 6, plus the 9 gets us a positive 3, and that's the same answer as the data table. So the equation is nicer if you have to find the position, like let's say at time 11.5 seconds. We wouldn't be able to use a data table for that, but we could use an equation. So if it's easy, probably the data table is easier. If it's an easy number that you can find a good pattern for, if it's something in between, you'll probably need to use an equation.